Hi, everybody. We are actually not talking about Chat GPT and labor force displacement today, as interesting as that topic is and how it's top of mind for everybody. Instead, and even though John Van Reenen knows a lot about that, and he's been a longtime friend and colleague of the IDE, we're going to talk about another piece of research that he's done, looking at the impact of regulation. I guess the obvious link here is that there are many calls right now to be regulating a lot of these new AI tools. John can help us understand with this research what some of the economic implications of that are likely to be. Let's follow standard IDE seminar housekeeping. During the main body of the seminar, please turn off cameras and mics. And if you want, type questions into the chat window. However, John loves a little give and take. So if you'd like to ask a question midstream, if you think you have a particularly keen one, please feel free to show yourself, unmute yourself, and just ask John. Otherwise, we will have some time at the end for first Q&A. John, does that all work for you?
That all works for me. Great. Thank you.
Over to you, sir. Good to have you with us.
Well, thank you, Andy, and thanks so much for everybody coming along to be here. First thing is, can you see my slides?
Yep,
yes.
Got it.
You can. Everybody can see everything. Fantastic. So let me hide my meeting controls and get on with it. So yeah, so it's great to be back at Initiative of Digital Economy, and I'm going to share some thoughts today on regulation and innovation. This is joint work with Philippe Aguillon, who's a colleague at the Collège de France, and Antonin Beaujeau, who's at HEC in Paris actually now, as well as at the CP. So what is this all about? Well, as Andy said, there's a kind of a long-standing question in social science and economics of how does regulation affect economic performance, and in particular, the focus of what we look at here is on labour market regulation. It's not going to be regulation of the internet, but it's going to be on regulation of people at work, and whether or not that chills or fosters innovation. Now, if you listen to the TV or the radio or newspapers, then the usual concern people have is that regulation, red tape kind of inhibits or chills innovation and has a kind of a negative effect. So there may be lots of things you want to have about innovation, but there's people often think, well, there might be a downside to that, in the sense it may inhibit innovation, or it may help innovation, but it can also inhibit innovation. The surprising thing, as we started thinking about this, there didn't really seem to be a kind of a good canonical framework in economics for thinking about it. Lots of people talk about this, but in terms of actually developing a bit of a more formal structure for thinking about it, there wasn't something you kind of lift off the shelf in the same way you can lift off the shelf. How does tax affect the labour supply, or how does minimum wage affect employment? So what we try to do in this paper is we develop a kind of a model. It has certain features, so it takes seriously, which we have to, the fact that firms are really different, productivity and sizes of firms are really different, so it has to be built in to how we think about this. We want to allow firms to invest in R&D and investment and innovate, so that's something we explicitly want to have. And we also wanted to have this as a way of thinking what we can think, not just about the microeconomic effects, using micro firm level panel data, but how that kind of adds up. What's the overall kind of effect on the equilibrium effect of the economy as a whole? So that was the kind of aim we did, and with that framework enables us to think about how regulation can affect the distribution of firm size, which some people have, including myself, looked at before, but also how it affects the distribution of innovation and how those things interact together. And so that's kind of what we're going to do in this kind of model. Now, we're going to implement the model on, as I mentioned, on micro panel data on the universe of all firms in France. You might say, well, why choose France, apart from the fact the food is excellent and my co-authors are French? France actually has, it's the top of the world in terms of the indices for the toughness of employment regulation. This is from the OECD. There's different measures of here, and you can see that France is, joint highest in terms of toughness of regulation alongside Belgium. So, if you want to see if there's effects of labour market regulation, France is a good laboratory for trying to look at that. So, say if you compared it with the US, which is relatively unregulated, or the UK, it's a good country to look at. So people often say, wow, okay, the problems that France has had, these are linked to regulation. Look at graphs like this, or if you're more sophisticated, you look at changes of regulation over time and changes of economic performance over time. But of course, there's so many things happening at the level of the economy, it's very hard to know whether any change is due to the regulation or many of the other things happening to do with the overall state of the economy, interest rates, and so on. So we'll use microdata looking within a country to be able to really tease out the kind of causal effects. Now, politically, of course, there's been lots of attempts to modernize regulation of labor and other things in France and many other European countries, other countries around the world. This is not easy. The politics of this are very difficult because there's winners and losers from those changes, and often you get pushback from trying to make those changes. President Macron in France has been trying to make those changes, and he has received quite a bit of pushback. For example, here's some pictures about what happens, and it's happening right now in France as reforms are attempted. So in a way, this paper is saying, someone like President Macron is going to expend political capital to make these changes. Are they worth it? What's the potential benefits of those changes? Are they big enough in order to meet to overcome the costs of trying to do something about reforms in France? The other nice thing about the context we're going to look at is that, as in the United States, as in most of the countries around the world, regulations are dependent on firm size. So typically, if you're below a certain size, you're actually not subject to the regulation, or you're subject to less stringent forms of the regulation. And in France in particular, when firms get to a certain size, 50 employees, this veritable tsunami of labour market regulation comes down on them. So they have to create a works council with employee representation, they have to offer union representation, they have to have a profit sharing scheme, they have to spend a minimum percentage of revenues on training. They want to dismiss workers, they have to have a social plan which they agree with the unions, labour ministry. So this all comes down at this kind of 50 type of threshold. Now there may be many benefits from these, and we can discuss some of the benefits, but they're likely certainly to lead to additional costs. And the question is how firms respond to those costs. If you just look at, the first thing you can look at, and I've looked at this in previous work, is just look at the distribution of firm size. So this is what it looks like in France. So, this just says this is just a number of firms who have 1 employee, 2 employees, 9 employees, 50 employees, 100,000, so on. So, and then on the y-axis, this is the number of firms, this is the size. These are both on a log scale. And you can see what you see in just about every country in the world, which is the so-called power law of firm size. So in log space, the kind of density of firms is more or less linear, log linear, this is almost like a -1 coefficient. So this is the kind of famous Zipf's law, which you can see. There's a whole branch called econophysics, which is about this. But in France, the power law is broken, and it's broken in a particular place just at this regulatory threshold. So you can see there's a whole bunch of firms stacked up here who are around 49 to 48 employees. And then once you cross the threshold, the whole slope of the line goes down. So there's a lot fewer firms you might expect above 50 compared to below 50. There's another regulation at 10 employees here, which also has some effect as well. So this looks like, the law might be doing something in terms of maybe discouraging firms to cross the threshold because they fear what looks like additional costs when they cross that kind of threshold. So that's kind of the first thing which got us interested in looking at this. Now you might say, well, what about other countries? Here's the US by comparison. So this is all firms of 1 to 5,000 employees. So you can see in the US, this was actually before the ACA, when there was an introduction of a kind of 50 threshold. But prior to that, there wasn't any kind of threshold of 50 in the US, and you can see it's pretty continuous in terms of the firm size distribution. Whereas, as I showed you in France, there's more firms at the threshold. There's more small firms than you might expect and fewer large firms than you might expect. So this could be related to this regulation. That seems to be some, at least prima facie evidence that that could be something which is affecting firms' decisions. So what we're going to do in the paper is we're going to build up a little bit of a theory to understand this. We're going to think about this regulation as like an implicit tax that strikes when you cross the threshold, and then we're going to show you some static non-parametric analysis is a fancy word for descriptive statistics. So some descriptive statistics like the one I just showed you, but looking at the relationship between innovation and firm size. I'm going to show you that there's a valley of innovation just before this 50 threshold, consistent with the idea that firms are innovating less because they're afraid to cross the threshold. I'm also going to show you that there's a fall of the slope of that relationship between size and innovation just after crossing the threshold, again, consistent with the idea of a kind of a tax making firms reluctant to grow. And then we're going to push the framework a bit harder. We're going to say, okay, let's look at some shocks. Let's look at some exogenous shocks to the market size facing these firms. And we're going to use shocks coming from trade in the export markets. And I'm going to show you, unsurprisingly, that as the market size gets bigger, firms innovate more. They can spread their R&D costs over a greater number of units, so you see more innovation. That's true of a wide class of innovation models. But what I'm also going to show you is that firms respond much less to those opportunities if they're just below the threshold. So if I have like 45, 46, 47, 48.9 employees, I'm really reluctant to grow, even when I see this opportunity, because I know that if I do grow, I'm going to have to pay this extra costs. So that's going to also be the kind of more dynamic type of analysis that we do. So I'm going to stop there at that point and said, okay, this looks broadly consistent with the theory, but I'm going to go one step further. Maybe it's a bit too far for some people, but I go further. So I'm going to actually take the model then seriously. So okay, let's say we really thought this was a serious model of the economy. I'm going to try and structurally quantify some of the parameters of that model using some of our data, and then use that to kind of simulate what the overall effect of the regulation is. So thinking about the counterfactual as we removed all these regulations, what would happen? So I'm going to show you, if you did that, we estimate in our baseline kind of estimates that innovation would increase maybe by something like 6%. So what does that mean? It means, in terms of the growth rate of the French economy is like about 1.6% a year. If you remove these innovations, you could grow by about 1.7%, so about 0.1 of a percentage point. That might look small, but if you accumulate that over a long amount of time, that turns out to be quite a big effect. So if you actually look at the welfare effects of that, that's something like a kind of 2.5% increase of welfare in consumption equivalent terms. And so, that's just a dynamic loss. There's a static loss as well. That kind of more or less doubles the overall losses that people have thought. So that's something, it's, you have to, it's not saying that you shouldn't have these regulations, but it's saying that, they may have other benefits we're not measuring, and we can talk about those, but it's certainly saying that there's some cost of doing that in terms of growth. And the other kind of thing we show you that in terms of understanding where this negative effect comes from, it's the regulation affects the whole size distribution, as I showed you. There's more small firms. It reduces entry, which is also something we see. But the main effect is just it reduces innovation for firms who are kind of just below 50 and all the firms who are above 50 as well. And that overall effect is the thing which is driving the overall loss of innovation and growth. So that's the main result of the paper. So if you want to go, you've got it. But there's more. So the other thing we're going to do, this is the kind of maybe better news about the regulation, is that if you dig into the type of innovations which the regulation discourages, which we do, look at the different quality of the innovations, the different types of the innovations, we show that the main effect is from reducing smaller incremental innovations. The really big innovations, the real game changers, are not affected by the regulation that we see. And and we extend the theory to show that makes a lot of sense. So I mean, intuitively, if you think of you're a firm which is below the threshold, say you're 45, 46 employees or something, you're thinking of investing. What you don't want to do is do minor stuff, which make if you do minor stuff, you might get to be 55 employees, 56 employees, you get all this regulation, forget it, it's not worth it. But if you want to innovate, you want to go big or go home. You want to go swing for the fence, because rather than just doing this minor thing as going over 50, you just want to really make your go for the kind of big innovation. So we show theoretically and empirically the radical innovations are not discouraged. It's the more incremental innovations are discouraged.
John, are they increased enough to maybe pay for the slowdown in incremental innovation? Does that question make sense?
It does make sense. The answer to that will depend on how much you value the radical versus the incremental innovation, which is a hard question to answer. We do we try and make some estimates of that by looking at the effect on productivity of these different innovations. And we come to the conclusion that it reduces the overall losses, but it doesn't offset them. It maybe reduces it's a tenth, maybe up to a third of the effects.
Oh,
2/3 of the effect of 90% can still go through.
So not even half by your most generous estimate.
No, I mean that's our. I mean, but of course, it's hard to evaluate what the value of innovations are. So I think this is still an open question, and of course, that's looking at the private return. You want to maybe also, if you thought about the social return, which is much harder to get at, then that may also give you a different answer as well. So I think this is a kind of, I'll give you some evidence on that, but I think this is the kind of open question of depends on your kind of balance of value with the radical versus incremental. Hong, you have a question. Please go ahead.
Yes, thank you. So I was curious about any anecdotal evidence for how these firms are sort of coming across these regulations, or is it like their HR head that has to tell the CEO that you're going to be facing these restrictions once you grow past a certain headcount? Like, what is the sort of on the ground reality for these companies? Are they thinking about them every day?
Yeah, I mean, these are very well known in France. I mean, these are the things which have been discussed for 10 or 15 years about how to reform them. Companies have been complaining about them. Of course, the unions like them, so they're very much. I think we did this calculation. If you look at the number of firms over 50 employees, there's about 100. For every firm, for every 200 firms, there's one bureaucrat in charge of enforcing them. There's a very big enforcement ecosystem to enforcement. Of course, unions and workers representatives also try to enforce them. So they are quite well known and quite top of mind, and there's lots of discussion in them in the press. So I think they are well known, and they are kind of monitored. So both on the union side and also on the firm side. And it's also worth remembering unions, unlike the US, unions are not dead in France. About 80 to 85% of all wages are determined by union contracts, so they're still around. Great. Any other? This is a good place for any other questions. Shout out, because I can't see all your hands up. But okay. So if there's no other questions, or the moderator is not going to say chat, I think we can. Okay. So given there's lots of related literature. I mean, I've worked a bit on this AER paper, Lewis Garicano. We looked at the kind of firm size distribution. We didn't look at all at innovation. The closest paper is probably this Mukayama and Osatimian paper. They also look at innovation in the context of regulation, but they don't use any microdata. It's a kind of a macro level paper, rather than trying to look at some of this microdata. It kind of relates to lots of other literatures. Okay, so let me get into the guts of the paper, talk about data, model, empirics, and results. So the data we're going to use is this very cool data set. It's the universe of every French firm over a 13-year time period. These are all the tax records of firms, which we have access to administrative data, which gives us our main type of information we have on the companies, their kind of sales, their employment, their investment, and so on. We then match that to this data set called PATSTAT, which some of you may have heard of. So PATSTAT is the digitization of basically every patent in the world over the last 100 years or so. It's 80 patent offices, the US Patent Office, European, Japanese Patent Office, and so on. So we take all those patents, we match them in to French firms using this supervised machine learning algorithm developed by Matthias Lecoin. We use, in our mainline results, we use priority applications. So, an innovation might be taking out patents with multiple jurisdictions. We don't want to double count them, so we just use that, use the first time the first filing. And we're going to use lots of other things about the text, about the citations, to look at the quality and the features of these things. Now, of course, it is patent data, so it has all the problems that we know about patent data. We'll look at we look a little bit at some other measures like R&D and productivity. But the nice thing about patents data is we have all the patents for all the firms. So that's an advantage to set against some of the other disadvantages of patent data. And then the third data set we have is customs data. So we match in all the imports and exports data at the firm level using the kind of administrative data. So we have origin and destination product by country codes for every firm over the same time period, as well as the total imports and exports to every country at a very disaggregated level. It's a kind of a six-digit level. So we'll use this to construct our instrument. I'll show you how we do that using export shocks when we get to it. Okay, so here's the first kind of just out of the box descriptive statistics. So again, I just lined up the firms by size on the x-axis, and then looked at the fraction of firms in different size bins who innovate, get a patent on the y-axis. You can cut this in lots of different ways. You're going to see a similar thing. So unsurprisingly, the bigger firms are more likely to take out a patent. You see this kind of upward sloping relationship, but as you get to the 50 mark, there's this real slowdown, much less innovation than you might expect, just around here, the innovation valley. And the second thing you see is that the slope of the line also flattens out as you get past that 50 point. So both of those things kind of give you the suggestion that maybe some firms are being discouraged from innovation, and even the larger firms, the kind of slope of that, the gradient of the slope has gone, so the incentive to innovate may be declining as you get bigger. So that was the first thing we saw. We said, well, maybe there's something interesting going on. Maybe we should think about this a bit more seriously. So let me just sketch you out the model. I'm not going to go through all the tedious algebra. I just want to give you a flavor of what it kind of looks like. So those of you who are familiar, this is a basic Schumpeterian growth model. It's from Kletter and Kortum, so we just take that off the shelf, and then we just add in one extra thing, which we add in a tax which hits firms when they cross this 50 employee threshold. So this is the kind of innovation of the theory, if you like, and it's thinking of the regulation as a implicit tax. So this is the kind of classic way to kind of think about it. So just the way that the model works is that we think of there's a continuum of different product lines, or varieties N, we index those by J, and each of those varieties is going to be produced by monopolistically by the most recent innovator on that particular line. So a firm is characterized by having a number of different lines or products, varieties it's producing, and the more varieties you produce, the kind of bigger you are. What's going to happen in the model is that if you innovate, you're the most productive firm, you'll set a limit price. The price will be just below the marginal cost of the most recent inventor, which means that you'll be the effective monopolist on that particular innovation for that particular product line. How do firms innovate? Well, they invest in research and development. That buys them a chance of innovating in every period called Z. And that depends on the R&D spend, but it also depends on the past R&D spending as reflected in the knowledge stock, which is the kind of size of the firm. So those two things are going to give you a kind of knowledge production function, depending on your flow of R&D efforts, and also your past R&D efforts as represented by your firm size. So that's just straight out Kletter Kortum. So what that means is that this is a kind of Andy Grove and paranoid survive kind of model, because at every point you as a firm are at risk of being creatively destroyed by another firm coming in and innovating on a product line. So that might be from another rival incumbent. Andy's always very coming up with new ideas and getting replacing my ideas before I can write my new book on the third machine age. So he would be that's his X innovating on me, or it might be a total new entrant, a new PhD student, ZE, coming in and displacing me. So that's I'm in constant risk of that. On the other hand, I might innovate, and if I innovate, I displace somebody else. And when I innovate, my productivity on that new line is a step. This is this gamma crown, so the existing technology, and I now produce an extra line. I've grown by one more.
So, sorry, John. So there's no need to catch up before you innovate. You can leapfrog someone else's innovation. Basically.
You're leapfrogging, exactly. So
Okay.
yeah, so unlike the models where you have to go up and up and up and up, this is a model where it's undirected search, and if you get on that line, you just immediately, I mean, you're building on the knowledge of the previous incumbents. That's where the spillover comes. So when I innovate, I kind of increase productivity, and I'm just building on the shoulders of giants. So all the other efforts, I'm just immediately jumping over the top of that. So that kind of gives you, that's in some sense why there might be underinvestment, because the the inventor doesn't take the new person doesn't take that into account, and that there's a disincentive to innovate. On the other hand, I have business steel, and that gives me a very strong incentive to innovate. That could go in the opposite direction. So firm here's an example of a firm. It's got 4 different product lines, and the height of the line is how productive it is in each of these different product lines. And so the way the dynamics of the economy work, think of it like this. Here's a model. Here's a simple economy with 2 firms. Here's going to be firm I and firm I prime. Firm I has this 1 product with this productivity. Firm I prime has 3 lines. It's a bigger firm. And here's firm I. This is David Burrell, becomes very innovative, innovates on J. Here's his additional productivity, and he's going to just limit price the less productive person out of the market and become the new monopolist here. So we've gone from a kind of still 2 firms, but now this is 2 firms with both 2 product lines each. So that's how the economy works. And this is like there's 2 firms. We just do this for a massive firms in the entire economy. So what you can characterize as the innovation incentives pretty simply in this model. There's basically 3 regimes. There's a regime for small firms who are well below the threshold. So this is the kind of threshold and bar, and this is for the kind of very small firms. All this stuff is basically about the innovation production function. It's about the bang you get through innovation buck, this side parameter. It's about the step size. The bigger the step size, the bigger the productivity bump, the more you want to innovate. Your discount rate, the more you discount, and so on. That's all great, classic, awesome. For the big guys, the guys above the threshold, they have a lower innovation intensity per product line because they know that every time they innovate, they're going to pay this additional tax, tau. So that gives them a bit of a disincentive on each line to innovate. The guys who really get affected negatively are the people who are just below the threshold, the medium-sized firms, because they know if they innovate, they cross the threshold, they have to pay this tax on all of their workers, all their kind of 50 workers. So that gives them a really negative incentive. So if you look at this, the easiest way to do this is in the picture. So this is the unregulated economy. Bigger firms do more innovation because the previous thing was the innovation per line. The big firms have more lines, they do more innovation. I know that's what we showed you at the beginning. Big firms have more innovation. So here's the unregulated economy in the dots. But if you're in the regulated economy, you see this disincentive. There's less innovation just before the threshold, the innovation valley. And then as you get larger, the gap between the regulated and the regulated economy gets bigger and bigger, because on each line, think of this as more or less every line. On each line, you're doing less. So as you get bigger, that gap becomes bigger. So that's like this fall of the slope of the gradient that we saw in the empirical data, the valley, and then the fall of the slope and the gradient. That kind of matches it up. So we managed to kind of match up the simple things that we saw in the kind of the kind of cross-sectional analysis, which is quite nice. We can also look at the kind of employment size. So because we've characterized how the economy is, there's a set of flow equations of different size firms innovating, growing larger, growing smaller. That gives you some law of motion between firms of different sizes. If you solve all that for steady state, you get a firm size distribution. There'll be different firms of different sizes. Here's the unregulated economy. This just looks like the power law that we saw at the beginning. And here's the regulated economy. So what happens is you get this kind of mass of firms just before the threshold, because these are the firms who are reluctant to grow. So you get a bigger spike here. Even firms behind are also reluctant to become big, as they might have to grow. So you get this kind of this shadow of the regulation going down. And then if for above the threshold, you see fewer firms above the threshold. So again, this matches the kind of what we saw in the firm size distribution. Okay, so we've got the two elements now. We've got the innovation intensity for firm size. We've got the firm size distribution. Put those together and look at the aggregate economy. So you can characterize the loss of innovation in the aggregate economy. So we this is just to illustrate the theory. We've kind of given a bunch of parameters. Along here is the kind of how tough the regulation is. So this is in kind of tax space. This is the kind of a 2.6% tax. This is a much bigger tax. So relative to the unregulated economy, which is 1, we can see how as the regulation increases, this is how much innovation falls. So if there's a kind of tax rate of say about implicit tax of 2.6%, this is about 6% less innovation than you would see in the unregulated economy. So different parameters will give you different results, but this kind of gives you some flavor of how you can go from that model to thinking about the aggregate kind of losses of innovation. Okay, so that's it on the model. Any questions? It's all hopefully pretty straightforward. And if not, I can get you into the real guts of the paper, which is the empirics. Okay, so let's do it. Okay, so the theory matches the simple empirics. Of course, the theory is designed to match the simple empirics, so that's not surprising. But we have the firm size distribution, we have the firm's innovation relationships, but we want to push it a little bit further. So here's our main empirical strategy. So what we want to do is we want to measure changes in the incentive to innovate, and the wide class of innovation models, like for example the one my former colleague Reenen, the one he would write down is to say that one of the main things affecting innovation is your market size. The bigger your market, the more incentive I have to innovate to get profits from that market. So we're going to construct a measure of that demand shock using the growth of the firm's overseas market, and it kind of leverages off this paper by Hummels et al. And it's a kind of a Bartik type of instrument. So because we got all the French customs data, we can characterize the export markets of all of our firms. So we define a market to be a 6-digit product, S, to a destination country, J, at a time T. And then we're going to calculate for every firm the share of the exports across different markets. So that's going to give us a kind of a weight, this kind of omega term. Then we're going to interact that weight, that's your exposure to these different markets, with the growth of those markets in subsequent periods. And this is going to be our kind of delta kind of I term. So this is going to be like all the imports going into that market, excluding things coming from France, which could be the endogenous element of that. So our instrument's going to look like this. It's going to be the change in market share multiplied by the export intensity, multiplied by the aggregation of the weighted growth of the export markets across all the markets the firm operates in. So the intuition is the following. So think of it as there's a French firm called the Groupe Bull, who produce a lot of computers. They were selling a lot of computers to China in 1999. Then, for the next 10 years, China grew like crazy because it joined the World Trade Organization. So it was using loads and loads and loads of computers. So Groupe Bull has had this massive positive demand shock, not because it's done anything itself, because it was lucky to be in China at that point before China, the Chinese computer market, the demand for Chinese computers kind of took off. That's the kind of idea. That works very well, and a lot of trade people use this as a kind of market size type of shock, and we're going to use it here. And of course, there's a whole literature now on these kind of Bartik shocks and the things you have to do to worry about them. We do all that in the paper. It seems to work pretty well. Okay, so that's the shock, the delta S. We expect that to have a positive effect on innovation, but really we're less interested in that as to how that affects how the effect of market size and innovation changes for firms who are of different size. And in particular, what we're interested in is that, if you're a firm which is between, say, 45 and 49 employees, just the left of that threshold, you respond a lot less to this shock than for the bigger and the smaller firms. Because if the regulation really is having this kind of discouraging effect, if you really expect to see a discouraging effect there, the firms just below the threshold. So that's going to be our key interaction. Now, of course, we want to saturate the model to make sure it's not being driven by anything else. So the left-hand side is the kind of growth of patent activity. The right-hand side is the demand shock. This is the delta S. We're also going to control for you're near the threshold. We're going to control for a flexible polynomial in firm size, because bigger firms may respond more to the shock than smaller firms. So more productive firms may respond less than less productive firms. So we'll allow for that. We'll allow for linear effects of size. We allow for sector dummies, for time dummies, to make sure really we can get this discontinuity around the threshold. So that's going to be a thing we look for. It's this kind of beta3 less than 0. I mean, the dependent variable is this kind of a David Holtermanger shoe version of patents, delta patents over average patents, or otherwise. In the paper, we go through all the other econometric estimation issues you could think of, like using Poisson count data models, using other kinds of arc sign models. Everything looks very similar. So this nice simple way works pretty well. Okay, so that's the kind of model. Yeah, please.
Just a quick question to clarify. So I guess here the concern of endogeneity is that firm size or demand for a product might be correlated with innovation, and you want to disentangle that demand from the innovation function, basically, right? That's why you want to get the demand shocks from China as opposed to just looking at firm size. Is that correct?
Correct, because of course the innovation could affect firm size, or there could be a correlated shock between the growth of the actual market and the growth of innovation. Yeah.
Okay. Thanks.
And we're also going to lag these by a couple of periods, because you wouldn't expect the effect to turn up immediately. You've got to do the R&D and then get the innovation. So we do in our baseline, we do T-2, but we also do other kind of lag structures. This works pretty well.
What is L star again, by the way?
So L star is equal to 1.
Oh, okay.
Between 45 and 49 employees and 0 otherwise. So it's picking up those firms exactly left of the threshold. Again, you could use 43 to 49 or 47 to 49. It's going to give you something similar. Okay, so so any other questions? Sorry, I should yeah. Great, thank you for that question. Okay, so what are the results like? Okay, so here's the linear effect. So positive and significant, it's saying that if you increase demand by 10%, you increase innovation by about 11%. So there's a kind of elasticity of about 0.1 between the shock and the future innovation possibility. So it shows you the kind of in the reduced form that there is some positive effect. We also find that big firms respond more than small firms to that shock. That's consistent with a class of models where it says that distance to the frontier matters. There is a differential effect. Again, that's not a focus of the model, but just something which comes out of the empirical work. The key thing for us is this kind of whether or not the firms who are near the threshold respond less than firms away, and this is this strong negative coefficient that you see here. This is just looking at conditioning on different controls and different kind of variables. You kind of see that there's a negative effect no matter how you look at it. It's probably easy to see this in the picture. So this is the implied marginal effect of that demand shock on innovation. So you can see, as I showed you, that bigger firms respond more to that shock, but as you get around the threshold, the firms are much less likely to respond to the shock. So by the time you get to 49, there's basically no response to the shock at all, or even a slightly negative response to the shock. So this is consistent with the kind of the theory which says that firms who are faced by this demand shock respond, but they respond a lot less if they're under the threshold. Okay, so in some sense, those are the kind of we've checked the qualitative implication of the model. We've seen it's through the cross section. We've seen this kind of dynamic type of effects going through. We could stop there, but we wanted to go a little bit further. So we then wanted to say something about how this kind of adds up to think about the aggregate kind of economy in France. So what we're going to do is we're going to calibrate some of the parameters in the literature, but we're also going to do some estimation from the French data. So there's kind of 5 kind of key parameters here. One is related to how the innovation cost function looks like. This is basically related to patents and R&D. So we take this from a paper which has used a regression discontinuity design of French R&D tax credits. So that's about 1.5. That's the kind of bang for the buck of R&D. Innovation step size maps into the aggregate price cost margin, which we can use some other work that many people have done, and the discount factor maps into the long run rate of the growth rate of the French economy is about 1.6%. The 2 key parameters we estimate from the data, one is the kind of output adjusted wage, which depends on the firm size distributions, like the Powell law, which we have. The really key parameter is the magnitude of the implicit regulatory tax. So we do a lot in the paper about how you can estimate this. So the baseline thing I'm going to show you is we estimate this from how the slope, the gradients of that relationship between innovation and firm size changes around the threshold, comparing bigger firms to smaller firms. So I showed you that the slope of the line as you cross the threshold flattens, and the more it flattens, the bigger that tax is going to be. So, you know, like in the model shows you exactly how that maps backwards, but intuitively, the flattening of that gradient maps directly back into the kind of implicit tax rate, and that's what we do. So we have a tax rate of about 2.5% when we do that. But, you know, I should say these things in brackets are the things we do sensitivity to. So I'm going to show you sensitivity to how these differ for different values of that tax rate. So that's going to be our baseline estimate. But I'm going to do a couple of experiments around that to see how the losses are sensitive to the kind of tax rate, which they are, because obviously the bigger the tax, the bigger the loss. So just to give you an idea about this, here's our kind of aggregate innovation rate. Depending on the tax, we get a tax of about 2.6%, which suggests about a 5.8% pool of innovation. So, you know, innovation in this model maps directly into aggregate growth. So that's approximately increasing the growth rate of the French economy from, say, 1.6 to 1.7 percentage points a year. So 0.1 percentage point. So not nothing, you know, not amazing, not huge, not doubling, but certainly, you know, not trivial benefit from getting rid of the regulation, if you wanted to do that, or reducing the regulation. So that's the kind of headline result, if you like. We can also decompose that using the theory. So the nice thing about the theory is that it gives you a way to decompose the regulation. So what we can say is that here's innovation with the tax, here's innovation without the tax, and we can divide this, and we can say, okay, let's imagine we had an economy where the size distribution looked like it did in the unregulated economy, but the innovation intensity was as it is in the regulated economy. That will tell us how much is just due to the loss of innovation. And then we can say, well, okay, well, let's do the other kind of thing. We say, well, let's change the size distribution of firms as we see, we get more small firms, but keep the innovation intensity per firm of different sizes the same as it was in the unregulated economy. It's like a shift-share type analysis. So we have the kind of, if you like, the within, the between. We also have an entry-exit term here. So if we calculate all that, it turns out that 4/5 of the effect is all from this first term. So it's from, if you thought about this as the kind of, you know, firm size changes and misallocation, that's much less important than just the reduction of innovation. So the dynamic innovation effect that firms are reducing their innovation is the main reason we get this kind of overall loss of growth. So, you know, we do a bunch of things here on sensitivity. As you can see, it is sensitive to the kind of tax parameter. That's the kind of key thing. So we did a little bit more on the tax parameter. So as I said, the way that we kind of measure the tax parameter is from this change of the slope between innovation and firm size. We can instead say, okay, well, instead of doing that, let's look at the dynamic response. So we can look at how firms differentially responded to that shock, comparing small firms with large firms. Large firms are responding less than small firms. So we can use that dynamic model to also estimate the cost of regulation. Now, when we do that, we only do that for exporting manufacturing firms because we're using goods. We only have goods exports. We only do it for exporters. So we only do that for that subsample. Now, that subsample is where we get where most of the innovation takes place, or big fraction of innovation takes place in France. So the losses are actually much bigger. So rather than 6%, it's more like 14%. But the nice thing is, whether or not we use the dynamic moments, or we simply use the change of the slope, the static moments we used earlier, we get very similar results. So it's suggesting that it's a kind of showing the robustness of the results to using different parts of the data to kind of estimate the loss of innovation. So that's kind of there. Now, the next step, of course, is we can do welfare. So a lot of people forget, including Philippe sometimes, that innovation is not the same as welfare, because to do innovation, it costs you resources. You've got to spend more on R&D. So although you might think that it's always great to have more innovation, it's not necessarily always great to have more innovation, because you have to spend more on R&D. And in these models, it's not it's not baked in that we have too little R&D. As I mentioned when I went through the theory, there's these two different effects. So you may have too little R&D because there's these spillover effects, but you could have too much R&D because firms are stealing each other's market share. That's the market share business stealing effect. And the social planner in some sense doesn't care about that. This is just moving shares from one to another. So that could actually could generate this kind of arms race with too much R&D. So we calculate this, and most empirical studies, including my own, suggest that there's too little R&D because the spillover, positive spillover effect dominates. And that turns out also to be the case in our context as well. So if you actually do a kind of calculation of the utility loss, you have this benefit from growth, you have this R&D saving, and the growth benefits way outweigh the kind of R&D saving. There's also this static efficiency type of term, which we it's difficult to get at that directly from our model, but we know that's going to be negative. So we can do a lower bound, if you like, of the losses, which is something like a 2.3% consumption equivalent loss. So this is, the static effect we know from, or we think from other work, is likely to be around about the same order of magnitude. So one way to think about this is the dynamic innovation losses more or less double the kind of static inefficiency losses. So if you ignore, you're really ignoring a lot if you ignore innovation when you think about effects of regulation. Okay, so that's the main set of results. So I'm going to pause there before I get onto some of the extensions for kind of questions or thoughts. Yeah.
Could you elaborate a little bit more on this static efficiency point? So like, what is the overall literature say about the loss of static efficiency within this setting? And like, yeah, and I guess it's sort of like the descriptive intuition behind these efficiency.
Yeah, no, it's because of the fact that even if you kind of switched off innovation, because of the fact some firms are more productive than others for, say, exogenous reasons, you will, from the regulation, you'll get a misallocation of resources because you'll get too much output for the small firms and too little output for the large firms. So even without innovation, if you just fix productivity exogenously, you'll still get some static efficiency losses. So in the previous work, like my paper with Louis Gaudin and Claire Lalage, that's the thing that we focused on, just fixing productivity and looking what happens when you have this type of regulation. So that's the kind of static efficiency loss that you have. It turns out it's quite complicated to characterize that in the model without quite a lot of in our model without other assumptions. So in our model, all the productivity differences arise endogenously because of firms' innovation activity, rather than exogenously fixing the productivity levels in a different way. So because that becomes a very hard thing to characterize. Now we could extend the model by allowing those exogenous productivity differences as well, and that gives us a way of characterizing this. That makes the model extremely complicated to solve. This is all pretty easy to solve. This is like I showed you the equations. If we did that, so we've done some versions of that, but it made them. So we decided, it's a future to do it. So what we do is we lean on the other estimates, these efficiency losses, to make those statements. So so that's what it is. I mean, it might, it is something we'd like to do some more work on, but we haven't found a way to characterize it in a very clean way. But what we do know for sure is it's negative, right? We know this is negative. So this 2.3% is clearly a low bound. If you included that, you'd increase it. And the exact amount you'd increase it would depend on those kind of things. He said there's a really nice paper. So Daron has this nice paper in the 2018 AR where they have a similar model which has some of this ex-ante heterogeneity in the ability of firms to innovate, but there's no analytical solutions. It's all through simulation. The nice thing about this, we can do this analytically. Really, we don't need to do really complicated simulations to solve them. So we go back and forth, and maybe the next where we build that in as well. And I should say one thing, that this framework that I've described here, you can use this for a lot of different things. So any type of regulation, any type of tax, this is a framework, or all this Python code is going to be, it's open source. You can let anybody use it. So you can use this for doing this kind of in lots of different contexts.
I guess one other version of innovation that we can track, but it's harder to measure, is like cost innovation, which would not be patent data. It would just be looking at how you've improved the productivity of workers and your cost efficiencies. And I guess that would be related to this endogenously specified productivity factor within your model, right? Like innovation being linked to productivity gains as opposed to just looking at patent. Because a lot of companies, I'm guessing it would be interesting too to look at the distribution of companies in your data set that have created at least one patent over the last 10 years, which is those that haven't, and then sort of looking at the different industries. And I'm guessing a lot of them would be more like in tech and like more innovative industries versus more retail type industries.
Yeah, right? We have all the zeros in here, of course. So we have all the
right.
zeros, non-zeros, and that's kind of important. But you're right that some industries, we saw that exporting manufacturing sectors are more patent intensive than others. We have done some work on using total factor productivity estimates as a kind of alternative type of measure. And of course, the pure size dynamics also gives you something on that. So that also gives you some additional information you can see. So the patenting does increase TFP, but TFP is a wider concept than just the one. Yeah. Was there somebody else have a question? So, okay. Great. Thanks very much. So we got we got 10 more minutes. So let me talk about this quality of innovation stuff, which is very, very interesting. So we extend the model in a small way. So we keep the regular innovation as before, but we also allow firms to actually invest to generate radical big innovations. So it's going to cost more, but instead of just moving by one product line in the baseline model, you can move in multiple product lines. So if you say 3-4 product lines or something, so that enables you to make a bigger innovation, but is more costly. And if you put this through the theory, what it gets is this result I said at the beginning, that the negative effects of the regulation is mainly an incremental innovation, because if you are going to innovate, you much prefer to do the radical innovations and the incremental innovations to avoid being caught in that kind of very unattractive period, just to the right of the threshold where you've only got 55 employees paying all the regulation and not having much size. So in the theory, this is what it looks like. And here's the kind of size versus the two types of innovation. So you see less incremental innovation, just as you saw before, but no effect on the kind of radical innovation. It's pretty smooth. So how do we now the problem empirically is how you measure radical innovation. So we do it in a number of ways. We know that we use various text measures of novelty and originality and so on. But I'm going to show you the most simple way, which is to use future citations. So what we do is we take for every technology class year cohort of patent applications, we follow all the citations to those patents, and then we define a radical patents to be one which is in the top 10% of the citation future citation distribution, and incremental to be in the bottom 90%. And we show lots of different thresholds in the paper, but we'll take this one just as a simple one. So if you're in the top 10% of guys who get cited in the future, you're radical. If you're above 90%, you're incremental. And this is what it looks like. So very similar to what the qualitative predictions of the theory said. So incremental, you see the valley of innovation, valley of death. You see the fall of the slope. But the radical is basically no effect. If anything, the slope actually seems to increase afterwards. So, this lines up very much with this intuition and also the theory that the negative effects are really solely on these kind of incremental innovations. And, if you're worried why 10 versus 90, we can do the cutoff at 15% or 25%, basically the same kind of story. It doesn't make any difference for the radical innovations. All the negative effects are coming from the incremental innovations. So the second thing that we do on this is we see how the response to shocks differs. Remember that was the cross-sectional thing. This is the response to shocks thing that I just mentioned. And you can see that if you look at this kind of marginal effect of the shock, this is the incremental, just as you saw before. Look at the radical, basically no effect whatsoever. So, this is the kind of proviso, I guess, to the conclusion that regulation has these negative effects, as Andy and I were discussing at the beginning. It depends on the kind of innovations that you care most about. So if all you care about is the radical stuff, you could say, well, no problem. If you care about the incremental stuff as well, I think, I do care somewhat about the incremental stuff, it still has these benefits, then, you still have these costs. And, some of the calculations I mentioned, okay, we offset some of the costs, but we don't really offset all of the costs by the radical stuff. Okay, so I'll leave 5 minutes at the end for discussion, but just to conclude, I hope I've shown you that regulation does have these dynamic effects by affecting innovation incentives. And we've given you some theory as well as some empirical work, which says this prospective regulatory costs discourages innovation, particularly for firms below the threshold, but also for firms above the threshold, because every time they grow, they have this implicit tax on growth. And there's evidence for this both in the kind of non-parametric cross-section and also from this dynamic analysis using shocks. And the aggregate effects look non-trivial, maybe about 5 or 6% fall of innovation, 2.5% fall of the welfare loss. However, with this caveat that it's kind of confined to incremental rather than radical innovations. So, caveats, we haven't, all of this is a kind of like a public finance paper. We've looked at the cost of the tax. We haven't looked at what you could do with the tax, spend more money on things we care about. So we haven't done that. The way I think about this is that, whatever your views on the benefits, you've got to kind of weigh some of these costs against those benefits. So it's a helpful part of that overall cost-benefit equation. The other thing I think is that, if you're a very Chicago economist, you say, well, you can look at the benefits by looking what happens to wages around the threshold. If workers really care about these things, it's an amenity, so they should be prepared to take lower wages to compensate them for this amenity. If we look at wages around the threshold, we basically don't see anything. So a kind of real Chicago person would say, well, that shows you that the workers don't really want to have the unions around to know what to do. They don't really care about it. Yeah, I'm less of a Chicago economist, because you could also say there's restrictions to how there's unions and things, so the wages may not be fully revealing these compensating differentials. But that is one bit of information which we go into this. And we talked about this this kind of, we've actually covered these already. So how important is radical versus incremental when you better estimate these spillover effects? We'd like to incorporate some more of this ex-ante heterogeneity that Hong and I were talking about, maybe to get a bit of better handle on those kind of static efficiency losses, make this more complete. But that's it. That's what I got. Thank you very much.
Thank you, John. So I'll be moderating the Q&A. Are there any questions in the chat, or if you want to throw me any questions? But also, I just wanted to follow up, taking this break and follow up to the industry point, which is that could you potentially draw those incremental versus radical lines for different industries? Because certain industries would look more like the radical type, and others might look more like the incremental type. So then you sort of build a new sanity check almost. Like, I'll be very curious to see what tech looks like for that patent exploration. Like, do we see a straight line up, which means that technology companies are pretty insensitive towards this 50 threshold, versus I don't know, maybe a garment industry, right? Maybe they're more sensitive to that 50 threshold, but also with regards to economies of scale on each industry are very different too. Right?
Yeah. No, that's a great point. I mean, we did a little bit of that by comparing the kind of exporting manufacturing sectors versus the rest of the economy, but we could drill down more and look at more of the intentionality. I mean, there's a kind of trade-off because, you know, we want to have this contrast around the 50 threshold. So there's not so many firms around 50, and the more you by industry, the thinner and thinner the data gets. But
right.
we can do some more around broad industries, as you say, maybe focusing on some of the more high-tech sectors versus the lower sectors. That's a good.
Mikhail Batikas has a question saying, considering the data is until 2007, could digitization mitigate the effect of regulation?
Could what mitigate the effect?
Could digitization, so the adoption of IT. Yeah.
In what, I guess, in what particular way? So
I guess in increasing productivity, I think he's referring to, like per worker productivity.
I mean, there's lots of ways. You're right. There are a lot of ways that you can mitigate the regulation. So, I mean, one way would be to say, okay, if I'm, say, 49 employees, I want to grow bigger. Instead of employing more workers, I might use more technology, and I might adopt more digital technology, or I might use more capital, or I might work my workers longer hours. I might use more skilled workers and less unskilled workers. You can see all of those things in the data. Actually, you see firms as they get to the threshold doing all of these substitution margins. So it's it's exactly, economics works. they do these things. And if all those things were perfect substitutes for workers, the regulation would disappear. So it's a Coase theorem. So when you have perfect substitutability, you completely unravel the regulation. The problem is these things aren't perfect substitutes. Digital technology isn't a perfect substitute for labour. You can't work workers, infinite number of hours. You've got the working hour week. So really, it's all about that elasticity of substitution between the different things. So we do some characterizations in the paper of how big or small those type of elasticities are, and show you how that would reduce some of the cost of the regulation. So they do reduce it, but at least in our estimates, those substitutability parameters are not huge. Like capital labour substitutability is there, but it's not an enormous parameter. It doesn't really offset the magnitude of the regulation losses very much. But you're absolutely right. There's a whole panoply of things that people are doing to try and substitute around for the regulation. That is going on.
An interesting sort of like test for that could be maybe to look at the productivity, the average productivity of companies near the 50 threshold. Like, do we see a big spike of productivity near that threshold? Right.
You do. So you see exactly what you expect. You kind of see firms that you think look unusually productive to the left of the threshold, because they, like in the US economy, these firms will have grown and got bigger and would be bigger. But in the French economy, the firms are reluctant to grow, so you see the more productive firms to the left of the threshold.
So is that type of spike in productivity not considered to be a version of increment? I mean, I guess, again, back to the patent question, we can't measure that, but it is a version of innovation to be very productive and be able to cut costs significantly, right? It is.
Well, it's levels rather than growth. So I think the innovation thing would be a change of TFP. That would be the kind of outcome look at here. So if you look at the growth of productivity, you see less of a growth of productivity for those because they're reluctant to invest and make increases of the productivity because they again hit the regulatory boundary. So that's the other things that you can use to get at that exactly that thing you're describing. Now, of course, TFP is tricky to measure. So
I see. You want to change the A in the ideas in the model as opposed to just
TFP perfectly. Then the static stuff would just be the distribution of A, and the dynamic stuff would be the evolution of A, and that would have the dynamics of the ones I've kind of described here with the innovation response.
Let's see, any other questions? I think that's it. Thank you so much for your time, John.
Well, thank you very much. We've gone 7 minutes over, so thank you for your generosity in giving me more time. It's great questions. It's been a lot of fun. And if people have other questions, other thoughts, just ping me. I'll hang on for 5 more minutes if anybody wants to stay in the Zoom room. So
thanks, John. Appreciate it. We'll look forward to seeing you soon.
Take it easy.
All right. Cheers.
So